Welcome to Explore, Discover Manufacturing Wisdom with Lynn. 3D printing technology is well known for its compatibility with various manufacturing industry, such as aerospace and flight. Today, I will show you 9 latest applications of 3D printing in aerospace in 2024, and how this muses of modern manufacturing changes the flight industry in a new and exciting ways. Number 1, in SpaceX Starship launch. 3D printing technology playing an important role in SpaceX's Starship development. Metal 3D printing creates engines chamber and turbo machinery for Raptor engines, reduce the number of parts, makes it lighter, easier to assemble, and more environmentally friendly.
I have a question. I heard SpaceX uses Inconel. What is it?
Well, Inconel is a group of austenitic nickel-chromium-based superalloys. With the help of 3D printing, it can handle high temperatures and makes cooling channels inside the engine parts. Number 2, in Tiangong 2 satellite. This Chinese satellite utilized 3D printing technology in a unique way to make fuel tanks 30% lighter than normal. 3D printing also makes high-resolution parts with accuracy as low as 1 millimeter rate, which benefits the satellite's position control system. Number 3, in composite aerospace material. The mixture of materials in 3D printing makes complicated and light aerospace end-use parts. This technology is popular for its lightness because it means less fuel use and pollution. Also, composite materials can easily get the best mechanical qualities for a certain use. Number 4, in high-fatigue resistant titanium alloy. Aerospace parts are loaded and unloaded many times and need to be very resistant to fatigue cracking, which is exactly the advantage of titanium alloy. 3D printing titanium metals reduced a large amount of delivery, maintenance, repair, and overhaul times. Number 5, in liquid rocket engine. 3D printing works especially well for complicated and high-performance parts like rockets. IAF discovered that 3D printed rocket engine parts can cut production time by up to 70% and costs by up to 50% compared to traditional methods. Number 6, in 01 Space OSX-6B rocket. 01 Space uses 3D printing to build an attitude control power system with lower price and less production time. OSX-6. B rocket's first flight symbols a big step forward in the use of 3D printed parts in flying systems. Number 7, in Tiansheng 101 satellite. Tiansheng 101 satellite have the first structure in the world to be made operating 3D printed lattice materials. With the help of 3D printed grid structures, this satellite is 20% lighter than using traditional building method, and its structural integrity has also improved by 15%.
Why they name it as Tiansheng?
In ancient China, 4-horses chariot accommodates 100 soldiers called sheng. Tiansheng indicates large number of troops. Number 8, in rocket engine gas generators and combustion chamber components. BLT, as the leader in the field, uses DMLS to create 3D printed parts. They already cut off 20% weight of rocket's gas engine machine and improved its thermally efficient. Number 9, in eVTOL engine. Electric vertical takeoff and landing vehicles are about to change the way people get around cities by air. Joby Aviation is using 3D printing to make whole engines with less pollution and flexibility that one can make samples and changes quickly.
Anybody knows why the E in eVTOL is lowercase? That looks a bit weird.
In conclusion, industrial 3D printing market is rapidly growing in aerospace industry. Relevant statistics show that the annual growth rate of recent 5-year is 22.4%. It will totally change how planes are planned and built by reduce waste and stay green. The tools, technology, and materials of 3D printing in the use of airplanes are all getting better, but still has a lot of room to grow. More standards and licenses are still required to convince the market about the effect of 3D printing. Thank you for watching. We want your advice and opinion. If you like this video, don't forget to subscribe XMAKE for more knowledge about 3D printing.